Good morning, everyone. I want to welcome you to NECEC's March Emerging Trends Series session focused on building our world with low carbon materials. Allow me to introduce myself. I'm Joe Curtatone. I'll now be beginning my 4th month soon as the new president of NECEC, and very excited and delighted that you're able to join us here this morning. We hope what you'll find to be a great program that is both interactive and engaging and informative in store for you today. And let me kick it off by saying, as we all know, we talk a lot about climate mitigation, and we're most often focused on sectors such as transportation and clean electricity generation and energy efficiency. But what is really emerging and gaining greater velocity, sometimes overlooked, is the built environment, which is a major contributor to greenhouse gas emissions, particularly the materials that make up our buildings, our roads, and other critical infrastructure. Concrete and steel, the materials that we will focus on today account, if you don't already know, for roughly 15% of all global greenhouse gas emissions. And we are going to focus today's session on how do we meet this challenge with technology and policy innovation. Now, it is my pleasure to introduce a key ally in our efforts to educate policymakers about the value of creating markets for low carbon building materials, Massachusetts State Senator Cynthia Creem. Senator Creem has served in a public capacity for more than 30 years. We thank her for that and her leadership. First as a member and president of the Newton Board of Aldermen, and then as a member of the Governor's Council prior to becoming a state senator in 1999. Senator Creem serves both as the majority leader in the Massachusetts Senate and as the chair of the Senate Committee on Global Warming and Climate Change. I want to welcome her, and please join me all in welcoming State Senator Cynthia Creem. Senator, the floor is yours.
Thank you.
Thank you for being.
Thank you, Joe. And I followed your successful political career, admired you as the mayor of Somerville, but I don't know whether that's something I should think about, but you quickly in and out and figured the private sector might be a better way to go. So thank you for your leadership in the certain political circles. So I also want to thank the New England Clean Energy Council for putting on today's webinar. It's so important that we do this. I'm so glad that we're starting a conversation about embodied carbon and low carbon building materials. That conversation is long overdue. Massachusetts has made great strides in reducing emissions in the electricity sector, and we put a tremendous amount of work into figuring out how to decarbonize transportation and building operations. But despite all efforts to figure out how to make buildings more efficient and how to heat and cool them without fossil fuels, we've given very little attention to the materials from which these buildings are made. When people think of greenhouse gas emissions, they tend to think of power plants, SUVs, furnaces. They probably don't think of steel and cement, even though those materials account for roughly 15% of global emissions. That needs to change, because if we're really going to achieve net zero by 2050, which we need to do, we have to take advantage of every opportunity to reduce our emissions, including building materials. In Massachusetts, government has often led by example on climate issues. State agencies have made early pushes for energy efficiency, for solar, for zero emission vehicles. Now it's time we do the same thing for building materials. Low carbon building materials are available to us right now. They can be implemented at no or low cost. They can deliver meaningful emission reductions. We just need to take action. Partnering with NECEC, I recently filed a bill that would make Massachusetts a leader in reducing embodied carbon emissions. The bill would require DCAM to establish guidelines requiring the procurement of low embodied carbon concrete in state projects, and to investigate the use of incentives for the use of low carbon concrete. I think this is the first time that we would be asking to take a really public position on this issue. But states like New York, Colorado, and Oregon have already taken similar steps, and I hope Massachusetts won't be far behind, despite the fact that we're usually the leader. So thank you to everyone for joining us today. And again, thank you to NECEC and to Joe Cortine for holding this webinar. To get embodied carbon solutions passed into law in Massachusetts, we need to raise awareness among policymakers and other stakeholders. Today's conversation is a great start. Thank you so much for having me here.
Thank you so much, Senator, for your leadership and for your continued support and partnership with us. It means a ton to NECEC and to the clean energy and climate economy writ large. We appreciate your leadership and look forward to working with you and your team as we move through the legislative session. I'm Jeremy McDermott, Vice President for Policy and Government Affairs here at NECEC, and it's my pleasure to turn us over to the panel portion of today's webinar. We've got a great panel with us today and really look forward to digging in on the technology and policy innovations needed to increase the market share of low carbon building materials, particularly steel and concrete. Here's how it's going to work. We're going to ask each panelist to introduce him or herself, talk about their organization, the work, and why they're doing the work they're doing. And then we'll launch into an interactive discussion about the ingredients necessary to advance the low carbon built environment. So I'm going to do my best to direct traffic, but mostly stay out of the way and let the experts do the talking. And I want to make sure that folks understand that we're going to leave time for questions and answers from the audience. Please do use the Q&A box at the bottom of your screen, and we will do our best to answer the questions either in real time or in the chat. Please don't be shy about your questions. This is designed to get your questions answered and really educate folks and inform folks about the opportunities of low carbon materials as we move forward. And now I want to turn to our distinguished panelists. First, we have Chris Neidl, who is a co-founder of the OpenAir Collective, which he'll tell you about, and a policy consultant at NRDC. He's got a long career of working in the renewable energy field, both internationally, locally, and at the state level, and really a bundle of energy and knowledge around low carbon materials. Next, we have Rebecca Esau, who is a manager of carbon-free buildings at RMI, a licensed architect, and is putting her knowledge to work at high performance buildings and driving the critical research in RMI's carbon-free buildings program. Next, we have two practitioners who are working on developing technologies and deploying those technologies. First, Adam Rauwerdink, who's the Senior Vice President for Business Development at Boston Metal. He spent the last decade leading global business development for new technologies within the energy industry, and is putting his talents to work at driving Boston Metal's new technology for steel production. And then our panel's rounded out by Eric Dunford, the Senior Director for Government Affairs at CarbonCure Technologies. He's focused on working with partners in the design, construction community, and policymakers to draw attention to low carbon concrete materials options and bring these solutions to new projects. With that, I am going to turn it over to Chris to introduce himself and start us off, and then we'll go down the line with each individual providing a little bit of context, and we'll get into the conversation. So Chris, over to you.
Great. Thank you so much, Jeremy. It's an honor and pleasure to be here and to be on such a great panel. My name is Chris Neidl. As Jeremy mentioned, I'm one of the co-founders of the OpenAir Collective. That's a grassroots global network that's focused on advancing negative emissions and climate policies at the state and national level as well. I also am very happily a policy consultant for the Natural Resources Defense Council, where I work on state level policies related to industrial decarbonization, particularly in the cement and concrete sectors. And in both roles, I've been involved over the last couple of years with some of the state legislation that's now been proposed and passed in different versions in multiple states, the Low Embodied Carbon Concrete Leadership Act, which started in New York, and then some of our members also have been driving real progress there in New Jersey, in others, Wisconsin, Virginia, and most recently Illinois. We found out about. So excited to be here. Excited to share my perspective on the sector and how public policy can intervene to accelerate progress.
Thanks, Chris. Let's turn it over to Rebecca.
Thanks, Jeremy. It's nice to meet everyone. My name is Rebecca Esau. I'm a manager at RMI within our carbon-free buildings practice, and I have a focus on low-embodied carbon construction. If you're not familiar with RMI, we are a clean energy nonprofit working across different sectors of the economy towards a zero carbon future. And as Jeremy mentioned, I'm a trained architect and I practiced for about 4 years in Philadelphia and New York City before making a pivot to the nonprofit world and joining RMI. Embodied carbon is such an exciting topic to work on as an architect. It's been so overlooked in the industry for so long, and building practitioners can do so much in this space. But most of my time at RMI is actually sort of driving policy efforts and helping different government jurisdictions and large companies sort of look at their scope 3 emissions and create some policies to reduce the embodied carbon impact of their construction projects. So with that, I'll pass it back to Jeremy. Thanks.
Great. And next up is Adam, all the way from Houston.
Native there to Boston, but in Houston today, overcast but warm Houston. Thanks for inviting me. Adam Rauwerdink, I lead business development at Boston Metal. We are revolutionizing how steel is produced. The NEC and many others have done tremendous work to change the energy industry, the electricity industry, growing the renewables. And Boston Metal is an example of how all of that work can then carry over to other industries. We're directly electrifying primary steel production. It's about 8% of global CO2 today that comes from steel, and we're working just in the greater Boston area to change that. Been with the company for about 5 years now, which has been an exciting period of growth. I joined as employee number 8. We're now over 80 and growing, so a very exciting time, and look forward to telling you a bit more about the work we're doing.
Terrific. And now Eric from CarbonCure.
Good morning, and thank you, Jeremy and NECEC, for the invitation to participate today. So as Jeremy mentioned, my name is Eric Dunford. I work for a company called CarbonCure Technologies. We focus on supporting the concrete industry and decarbonizing their concrete products. And we do that by actually enabling them to utilize carbon dioxide in the production of the concrete itself. So we are also, much like Adam, a rapidly growing company. We now have about 500 plus concrete producer locations that are using our technology. And we look to continue to expand that growth here in North America and abroad. So I also wanted to say thank you to Senator Creem. This is a really important topic. And 2 or 3 years ago, when I first started talking about this topic, nobody on the legislative side had ever heard about it. So it's really exciting to be here and having a conversation with the fellow panelists on this topic. So thank you, Jeremy.
Thanks, Eric. And before we dive into sort of the intersection of policy and technology, I want to level set on the technology. And maybe, Eric, I'll turn it to you to just talk about giving us a layperson's description of the difference between sort of traditional concrete production and CarbonCure's method, and just sort of talk through how that process works and what the greenhouse gas benefits are.
Absolutely. So my goal today is, if you weren't excited about concrete before or had never thought about concrete before, I hope you're excited about it by the end of today. But the really exciting thing is that concrete has this unique capacity to actually absorb CO2 and take it into its structure in a way that does not affect its performance negatively. So the difference between this kind of class of technologies that CarbonCure would fall under, which we would call carbon utilization, is that you can actually introduce carbon dioxide into the manufacturing process where it becomes absorbed into the concrete product. That has 2 benefits. Number one is that it actually allows you to take CO2 that would otherwise go to the atmosphere and store it and lock it away for centuries inside of concrete products. The second thing it does is that it does unlock some manufacturing efficiencies that helps producers manufacture their products with a lower carbon footprint. So those two aspects are what makes our business run. I would say as well, I think to the senator's point earlier, is that we are commercially active today in a number of markets and states. So again, this is something that is happening in the real world. It is not still a benchtop laboratory experiment.
And are there other technologies or other processes for reducing the concrete other than what CarbonCure is doing?
Absolutely. And unlike, I think, Adam's industry on the metals side, is that decarbonization of concrete is not going to be accomplished just simply through energy switching to renewables. There are 2 main strategies that are really important in this sector to understand. One of them is the carbon capture and utilization side. So there are other companies out there that are doing similar things to what we are doing, and that number of companies continues to grow. Columbia University actually published a study suggesting that this was going to be the largest place for CO2 to end up in the near term. And beyond the kind of use of carbon dioxide, the other strategy is what we would call cement alternatives. So the analogy that's often used in the industry is that cement is to concrete as flour is to a cake. So we can't actually have concrete without cement. Cement is the most emissions intensive source. And so if you can find different materials like slag and steel or ground glass that can act as a replacement to cement, that also reduces the emissions profile quite significantly.
Good segue. And Adam, I want to bring you in to talk about the technology that Boston Metal is doing and how it sort of stacks up into the industry of steel production.
Sure. Yeah, and as Eric mentioned, one of the advantages that you do have in steel is that, you know, if Boston Metal is successful and several others that are developing different solutions are successful, you can directly electrify steel production, move from a coal-based process today, which I'll explain, to a purely electricity-driven process, and that's where, you know, leveraging all the work that's being done everywhere else. But, you know, kind of a 101 level intro to steel. About 2 billion tons of steel made each year. So a good frame of reference there for those here in the US is the Golden Gate Bridge, 25,000 times each year. That's how much steel is produced globally. About half of that happens to be in China, but very much a national security issue globally. So every country has a bit of it, or most. Really two major ways to get to steel. About 70% of it is what we would call primary steel, coming from an integrated steel mill, blast furnace, the basic oxygen furnace. That's where you're using coal to produce new units of steel from iron ore. So the energy source is coal, the feedstock is iron ore. You get new units of steel. You also get about 2 tons of CO2 for every ton of steel that's produced. But that's 70% of the global steel. The other 30%, and one of the big advantages of steel is that you can recycle it really indefinitely. 30% comes from recycled scrap. So the feedstock is, you know, units of chopped up cars and chopped up appliances and buildings. You're using electricity there to melt that scrap. You do some adjustments to get the quality grades and compositions, but you get a new unit of steel from recycled steel scrap. So you can have a lot less CO2. So that's one of the areas that the industry is really pushing to expand. There's only so far you can go there, but that's an easy way very soon to get to, you know, much cleaner steels. But those are the two big sources. Boston Metal is kind of hybrid of the two. Our input is iron ore, but we're using only electricity. So it's taking all the carbon out of the process that we've used since the Iron Age to get to liquid iron, doing that eventually with clean power and decoupling steel from CO2 production.
So there's a direct link between Boston Metal's process and the need to electrify or to decarbonize the electricity grid. I want to bring in Chris and Rebecca. And Rebecca, I want to invite you to turn your camera on and then I want to ask you guys about the overall greenhouse gas impact of these technologies and how impactful it's going to be. So Rebecca, why don't you go and then I'll turn to Chris.
Sure, thanks. Yeah, I do think that there is going to be obviously a really large impact. I think I can't remember the precise number, but the concrete and steel industry account for a really big chunk of our global greenhouse gas emissions. And so decarbonizing those industries using the technologies that were just mentioned are going to make a really big impact in our building sector.
Chris.
Yeah, I mean, I think it's huge. I mean, if you look at those two materials alone, they represent the vast majority of embodied emissions in the built environment. And one key thing I think to really stress is they're also irreplaceable materials. You know, there are innovations and substitutes for concrete and steel, but if you look at a meaningful time frame for climate action for when we have to solve this problem, we're not getting rid of those in any substantial way within that time frame. So it's important to really, when we look at these materials, it's about the evolution and change of these materials, not the displacement or substitution. There are substitutes, but as I said, these are foundational to the built environment. So the the need here is to incentivize and encourage changes to the material. And what's fascinating, is Eric could speak to, is that doesn't involve disrupting the existing industries and displacing them with entirely new companies. It means serving those companies, bringing those companies along, whether it's ready mix or block producers, to implement these changes. So it's a really kind of fascinating, interesting project that we have ahead of us that's quite different from what we're trying to do in decarbonizing other sectors.
Chris, I don't know if you were teeing up a question for Eric or Adam, but I do want to I do want to encourage panelists to talk to each other and not cut me out, but cross-pollinate for sure. So Eric and Adam, I don't know if you want to respond to those questions about the GHG impacts, and then we'll get going.
I think just Chris's point, one thing to really drive home, which Chris is pointing to there, is that these existing industries are very expensive capital pieces of equipment that are installed, right? And they're actually also very difficult to set up new plants. So if you're looking at an urban area, finding a place to put a concrete plant where there isn't one already is very challenging, both from just a capital perspective, but also from a stakeholder perspective and just public governance perspective. So as Chris is saying, I think we always want to look for silver bullet solutions on the climate, but this industry, much like the others, is going to be challenged. There's not really one size fits all here, and we really have to look at how do we make transition for the existing industries easy, accessible, affordable, and help the industry move forward without putting some sort of challenge on the table that is not possible and is economically damaging at the same time. And that's only going to become more prevalent as we look at these Build Back Better proposals and infrastructure spending. We are not going to have new factories on board producing alternatives to concrete and steel. We are going to be using the existing materials, and therefore it's really critical that we think about how we help those industries transition and not look at just simply trying to switch to an alternative.
And is the same hold true on the steel side, Adam?
Yeah, certainly. I mean, you have 2 billion tons of steel production capacity in the ground with lifetimes measured in decades. So, a lot of the steel industry, when you look at, the carbon neutrality goals, it's mostly about the 2050 level. There's a few that are shorter, around 2030, but that's just the natural life cycle of, number one, when are new solutions available technologically? And number two, when do you reach kind of natural replacement cycles with the existing installed base? So that will certainly play out over several decades. But the impact from the Boston Metal side is that, if you look at the incumbent processes where it's largely scope 1 emissions, our process or any electrolytic process would drive that scope 1 to 0. You're going to be emitting oxygen. It really then becomes a question on the renewable energy infrastructure and how quickly that can grow, because it becomes very much a scope 2 question. Scope 3 is pretty small in the world of steel compared to the 1 and 2 you have today.
Yeah, I think one of the things that that Joe preaches from NECEC's perspective is the intersectionality of all of this. And this is a really good example of not only the sort of clean air benefits, the climate benefits, but the intersection of the grid and material production on the steel side. And then I think the sort of capture of carbon and embedding of carbon on the cement side for CarbonCure. Who are the skeptics in this space, and what are they skeptical about? And yeah, I'll start there. And this is a free for all. Anybody can jump in and take this one or start out.
I could say one thing on that quickly, I guess, is, well, there's the skepticism that goes along with it. Just looks like an incredibly challenging problem. These are called difficult to abate materials for a reason, because they are difficult to abate, both technically, but they're commodities. And so adding additional innovation to it can be really challenging from a competitive point of view. So there are people that are skeptical on that view. I think there's also, Eric and I talk about this a lot. I think Rebecca and I have had some chats about it too, is there's kind of a different paradigms or frameworks, I think, among policy activists, that some that come from the, how do we encourage innovation? How do we make change happen? And then sort of more of a protest framework, I think, that's more about, how do we sort of limit the bad guys or the industry? And so if you're approaching it from the former, you're looking at how do we create policies that are going to induce these changes, working in partnership with providers. And if you're on the other side of it, the conversation doesn't get that far. It becomes sort of more about, these are the emitters, and there's sort of an implicit sometimes suggestion that they should be shut down or replaced or something like that. And so that's really playing out, I think, in important ways in the policy sphere. Everywhere we've been working our activism for our concrete bills, we've encountered that. So I think there's sort of skepticism on that almost paradigm level, I think, that comes from sort of the more protest end of the climate movement.
Yeah.
I would say, sorry, go ahead.
Oh, thanks, Adam. I was just going to add to that, Chris, because I have experienced that as well. But I've also, a lot of my colleagues at RMI work within sort of electrification policy. So this is about, decommissioning the natural gas system in the US and switching buildings to all electric equipment. And it just, when I compare the two, like this sort of what we're doing here with driving low embodied carbon materials to building electrification, it just seems sort of easy, actually. Like the building electrification world is up against—
in quotation marks, to be clear.
Yeah.
Right, easy in comparison. So I try to tend to look at it, sort of put a positive spin on it, and I guess, and say that there's, it seems to be that there are more supporters in all of the different stakeholder groups than there are skeptics, which to me is, something very hopeful.
I think that's positive. And Adam, just before you jump in there, is I think that it's just really important that we distinguish between sectors. And I think there's a lot of sort of imposing of general principles, a lot of it taken from the electricity sector experience and just trying to put them on top of industries. And you really have to understand the critical sectoral differences between these different things and construct your policy from there. So I think that that's a thing that's sometimes missing as well.
Yeah, I was just gonna add that over in the steel industry, I think this is one thing that's quite exciting, actually, is that when I joined even Boston Metal 5 years ago, there was a lot of skepticism. The question, does the steel industry need to decarbonize? It wasn't really a settled fact at that point. There were a lot of skeptics that, we've been doing this since the Iron Age, it's going to continue. That has changed tremendously in the last couple of years, globally at that. And that's something that's exciting to see. And a lot of that comes from the work that everyone, many on this call are doing, and others on creating market pull, whether that's from buildings, that's from government, federal or state level procurement, that's the automotive industry, it's the renewables industry wanting clean steel in their renewable assets, it's the tech companies wanting clean steel in their data centers. So it's across industry really making it a life and death decision for the steel industry now that, hey, the market demands clean products. We have to find a way to deliver and do that as quickly as we can.
One other thread to add to the conversation here, and I actually see somebody in the chat has just cited what I was going to talk about, is that labor is a dimension to this that we have to consider. And again, I think it's important to all of us that we have good paying jobs in these manufacturing sectors domestically. That's good for the climate, it's good for the environment, it's good for employment, it's good for society writ large. And I do want to point out too that one of the challenges that I think we've encountered over time is that the status quo itself is a challenge. It's not necessarily a skeptic, but all change is hard. Legislative change is hard. People who know how to work procurement system in the purchase of these materials, even if it's an improvement that's being proposed, that's a change. And a change might mean that somebody is a winner and somebody is a loser. And so I think, again, one of the biggest immovable objects that I think that we've encountered over time is just how difficult it is to get people to think about a different model and to be comfortable with the fact that there is going to be some change and how that we can navigate that change in a way that doesn't unduly punish somebody or unduly reward somebody, I think is really the key measure of success.
Yeah, and Jeremy, if I could add to that too, is I think that another, just picking on what Eric said, is sometimes from a faraway level, if you're just approaching this from the lens of climate, there's a word that gets used a lot about the culture, the conservative culture, not wanting to change the status quo. And, there might be elements of that, but if you get closer to this, you realize there's structural barriers that any individual actor encounters when they want to try to make a change. And when we're talking about concrete and steel, this is what our environment is built out of. There's obviously a lot of sensitivities, as there should be, around safety and caution, liability structures and things like that. So when we think about climate policy, it's not helpful, I think, often to just say, oh, it's a cultural barrier. You really have to look at what the civil engineering profession, what different states and agencies really face, and incorporate that from a very early stage in how you design policy and what you advocate for.
There's a successful playbook that people have been using for long periods of time. It has worked to have, a built environment with a certain structural integrity. People know the drill, and if you're changing that playbook, the inertia is against you, right? I think, and taking a collaborative sort of approach is going to get you further. What I'm hearing is that's going to get you further than trying to sort of disrupt the industry in a more profound way.
I think if we want to really tackle a climate crisis, then you look for allies wherever you find them. And I think, again, it's everybody has a different lens on this, but we are all working in the same direction, and finding a way to have shared benefits in this conversation is what's going to move this ahead.
Couldn't agree more. So let's flip it around. Who are your champs? Who are your champs within the industries that you're working with? Both in the steel and concrete industries. And maybe Adam, I'll turn it to you first, and then Eric, and then Chris, and then Rebecca. Excuse me.
Well, I mentioned some of the champs when I was talking about skepticism, but I'll say now the champs are the steel makers, and that's been something that's exciting to see, is that globally that they are on board now. They are putting forward, you have executive support to drive the teams at the R&D level and the innovation and the technology teams within the steel makers to really motivate them. And that's something that, wasn't there a couple of years ago. So that's really where you see the internal champions within the steel company that give us a chance to get in there and really have meaningful substantive discussions and move the ball forward. It's exciting to see where that leads in the next couple of years.
I think much like Adam, when Chris, I think the comment you always make is that concrete is by definition local. It's a local business. You cannot ship concrete very far as a result. And also they have a lot of employees. So concrete companies are fantastic local employers. They care about their communities. They're invested in their communities. And I think that the partners that we've worked with to date, it's always inspiring to see how much they do for their communities in terms of donations and events and just the way that they support other people. So I would say that our customers as well, it's exciting to see what impact they have at that level. The other thing I wanted to point to is that we are seeing a really huge level of interest and investment from what I would call voluntary carbon markets. So the tech companies, a lot of the developers, the real estate property managers, are really looking critically at what they can do in their own portfolio. So they've done a lot looking at their own emissions from electricity and from natural gas and these things. Now they're asking questions around the buildings that I build, that's my real impact on this world. What can I do? And so we've been the beneficiary of working with a number of groups on that front that are supporting this and are actually putting themselves forward and helping to bring down the innovation cost to bring these things to market. And I think that's really exciting to see the power of private industry directed towards a change we know needs to happen. We need to do what happened with solar 3 times or 4 times as fast as solar did it. So to get there, we're going to need a lot of funding. We're going to need a lot of support. And on that point, again, I think Senator Creem and others, these early legislator adopters that are putting this issue on the table and saying, this is a real issue. You should take this seriously. It's just as important as the other things we talk about. Again, I can't thank them enough for what they're doing, because that's making this real and really kind of pointing to the fact that the government has power here over any other player.
Which is a perfect segue to the policy part of this conversation. And I'll turn it over to Chris and Rebecca to sort of get us started about, the way that they're seeing the policy landscape across the region and across the country and across the continent, and what we can learn from experience here in the Northeast.
Rebecca, you want me to go first? Sure. Yeah, I mean, just following on what Eric said, both the local and the government piece is, who are the champions of this? Really what's happening at the very local, county and municipal level, I think, is where the real innovation has really been set. When you talk about decarbonization policy for concrete specifically. So I'm thinking of places like Portland, Oregon, and Marin County, the Port Authority of New York and New Jersey, really just kind of pushing the ball forward. And so a lot of the credit really, I think, goes at that level. And then that bubbles up and starts to inform state and higher level policy. So a lot of champions at that level who deserve a lot of credit. So in terms of policy, I'll just say real quickly, and then, let Rebecca respond, is I think that it's particularly with concrete, the public sector has just such an enormous role in shaping outcomes, not just because they're, Eric probably has the stat handy, but, you're talking about 40%, I think, of concrete in the United States is procured by the public sector, a lot of that at the local level and state level. In addition to that procurement, you have the standards and specifications that are typically set at the agency level that are not only used for state projects, but usually are the points of reference for local government, even private sector. You have the capability to review, test, and approve materials, which also becomes sort of a guidebook for a lot of projects. So there's an enormous amount of power and influence that is unique, I think, among commodities when you're talking about concrete. And so they can step in as a early buyer and verifier of new materials that will have a incredibly important, in addition to the decarbonization of the enormous amount of concrete that the public sector lays, it'll have a huge ripple effect on how concrete is used and specified more generally. So I think policies right now focusing on procurement is really important because it also implies those other things. The state's not going to be procuring certain kinds of concrete unless that civil engineers have basically signed off on it. So I think that's why you see a lot of these policies are focused on procurement at this stage, which I think is appropriate.
Yeah, I agree with that completely, Chris. One thing that I've been thinking about in our work at RMI is these sort of like two different approaches to embodied carbon, at least like from the design perspective or from the demand side. In terms of looking at a building, you can look at a building sort of through like all of the individual pieces that make up a building, or you could look at the building as a whole. And so there's sort of two different strategy approaches. One is to look at materials. So, you know, we've been talking about concrete and steel as these materials, and there's policies that target these specific building materials. And the other way of looking at it is to look at like the end product, the building itself, and sort of look at the total embodied carbon of that building. And at least in the US, where we're seeing the most popular types of policy is back at the sort of material focused level. So policies that target concrete, target steel, and other building materials, that sort of buy clean type procurement policy. And it's really helping to send, as others explain, this like really strong demand signal across the market, especially these large government purchasers and large companies that are starting at the material level, are sort of influencing the market, and then that the products become available to everyone else. And they also are great because they sort of require this disclosure of embodied carbon content through environmental product declarations, and sort of set up a regulated way of doing that. And so we're seeing that, I guess, at the procurement policy level, and also at the building code level, which is taking a similar approach in the US, where they're looking at specific materials and trying to limit the global warming potential of those specific materials. But I do want to say briefly that these material focused policies do actually miss some other opportunities to reduce embodied carbon in buildings. These opportunities could be things like reusing a building, or using mass timber instead of concrete and steel, or designing a more efficient building. All of these strategies can really help reduce the overall embodied carbon content of buildings. But the sort of policy that would address the sort of whole building approach can be actually more complicated. So I think right now, the best route, as Chris mentioned, is to have that sort of material focused policy in place, get the industry comfortable with embodied carbon, disclosure, and how you actually track emissions through the manufacturing of materials, and slowly build on that to potentially work up to more of a whole building policy, where you're including all of the materials that go into a building instead of just, you know, a select number of materials. Definitely the whole building policy approach is more popular in Europe and Canada and other places, but really in the US right now, it's this material focused policy, which seems to be the most effective right now.
Chris, and then I want to turn it over to Adam and Eric.
Yeah, just to also really stress that these things don't happen by themselves because they're self-evident. I think that we've seen over the last couple of years, decarbonization of these materials has really emerged as an area of climate policy. And a lot of that is because of activists. And so I just want to give a shout out to some of the folks that are really driving things. I mean, Eric has had encounters with these folks, people like Sue Dorward in New Jersey, who are pushing the LECLA bill there. We've got, Julia Pooler, if you haven't seen her Girl Scout troops, amazing videos about low carbon concrete, is trying to push things in Wisconsin, Neidl Contin in Virginia. So there's a lot of people that are starting to converge on this from the grassroots that are really elevating it at the state level. And I think that a lot of the environmental advocacy groups are sort of following the lead of those activists. So that's been an interesting thing to see.
One thread that Rebecca had that I wanted to dig into is you mentioned the whole idea of transparency and disclosure, and that for everybody listening, I think this is one of the key things that policy has to do for us to get to that whole building kind of reality, and that management is that you can't really manage something you cannot measure. Like, we know that that's something we're taught in all sorts of fields. And in this case, if I were to ask you, what is the carbon content of concrete sold in Massachusetts today? We actually do not have a very good answer for that. And that just is one of these things that until we invest the time and money in terms of understanding what is the carbon impact of what we buy, it's very difficult for somebody to have a value proposition around reduction. And my personal belief, and I think what we're starting to witness, is that when you manage that impact and you report that impact, it's a lot easier for these innovations to take off, because people can actually look at those values and say, that's not enough, I need to do better. But right now, practitioners, and Rebecca, you were an architect in your former life, if you're sitting there wondering, what can I do with my project? It's very hard when you don't know what the baseline is that you're building from or designing from. And I think that one of the key things in the Buy Clean policy that California first introduced in 2017, we are seeing that in all of these later policies, is this idea that we really need good information on what is the industry capable of today, what is a real reduction, how do we track and measure that? And every piece of policy that touches concrete has proposed that as part of it. And in many cases, they have proposed incentives to help reduce the cost of going through those processes, because they are not necessarily a minimal thing to do for industry. So again, I think these policies, that's a good component of that.
So,
Yeah,
so
totally
transparency, go ahead, Rebecca, sorry.
No, I just want to totally agree with Eric. Disclosure is so important, and also having help for small manufacturers to create environmental product declarations is really, really critical.
Very similar in steel, where you have industry groups coming together. Right now, the steel industry doesn't have it, just like concrete doesn't have a defined mechanism for stating the exact embodied carbon in steel. So there's industry groups. Responsible Steel is one, where they're trying to put together a unified framework and get steelmakers to sign on board and certify their sites, so that the supply chain can have a gold standard to look to and understanding the embodied carbon. Right now, you talk to automotive makers, for example, their supply chain groups have to develop their own internal framework to try to figure out, as you're talking to different steel suppliers, how to really compare apples and apples. So that's something that the steel industry is definitely working to implement in a very near-term basis. You're also seeing, how steel is kind of traded. There's local markets, but there's global benchmarks for pricing in different regions and for the different products. And there you're starting to see, embodied carbon or green premiums show up. So you're starting to see, particularly just use Europe as an example, you're starting to see carbon surcharges on top of the index price. You're starting to see a carbon surcharge show up that's being passed on to customers. The other side of the coin is you're starting to see the green premium show up. When you do have low embodied carbon steels, they're getting a premium above that index price. So those mechanisms are starting to show up. But those in the pricing indexes, that will become the future as well, where that will be much more defined there. And through groups like Responsible Steel, it'll be much more defined in how to measure that at the individual plants. So,
Adam, from your perspective, is it better to have the industry sort of organically developing these standards and market mechanisms to reward lower carbon content product, or is there a need for a more standardized sort of government-driven transparency declaration regime?
I mean, with steel, it's the industry really, driving the framework at the moment. It's a lot of industry organizations. There's a bunch of, think tanks. There's across the supply chain getting involved in the process. But steel is a very complex production process. It seems simple, but there are a lot of different steps and a lot of ways to iterate even within the blast furnace and BOF route. So there's a lot of work that needs to be done to how to properly draw those boxes, and you really need the steel industry engaged in that because they know what's happening behind their fences.
I would say, though, that the unit of measurement, Rebecca described the environmental product declarations, like the industry has provided a tool that I don't think the government is going to, need to reinvent here. That tool exists, it is widely used. And the actual mechanism by which you decarbonize is going to be different in every sector, but the way that you track and report that information, that platform already exists. So we do have the good fortune that private industry has invested and developed that approach already, and we don't need to kind of go to the drawing board on that.
Well, and any good policy, whether it's driven by industry or government or both, is that conversation about what is the goal, what is sort of, how do you execute on it, how do you make it happen, and if there's a standard out there that has been coalesced around and accepted and achieves that goal, there's no need to reinvent the wheel. Rebecca, I want to turn to you, talk a little bit about the sort of buy clean versus sort of LECLA sort of materials process, and can you give folks just a couple sentences about the difference between the two policy approaches and what's happening in Colorado, and sort of maybe Chris, you can talk about what happened in New York for LECLA, sort of the policy debate piece of this.
Sure. I mean, I can talk a little bit more about the work we're doing in Colorado, which is a clean procurement policy, which is, sometimes I don't think it's officially called buy clean, but that's what everyone calls it.
Yeah. And
basically it's a little bit broader than the New York LECLA bill, which Chris can talk about, but it's broader because it incorporates more material categories. So it includes concrete. So we have all the different sort of concrete ready mix strength categories included in the bill, and we are they need to be essentially have a global warming potential or embodied carbon limit assigned to each of these categories. Other categories we have are steel, there's a wood category, there's an asphalt category, there's a glass category. So it's a lot broader. It's trying to tackle more materials that we know are high embodied carbon materials that go into construction. But it's the sort of the principles are the same because it requires the disclosure of the embodied carbon content of the product or material through environmental product declarations. And then the bill sets a carbon limit on those materials that, come online in 2024 or something, and then decrease over time. So it's sort of the same principle of like, you're looking at a group of materials, you're requiring that the manufacturer disclose the carbon content of these materials, and you're putting a cap on it. So maybe Chris can talk a little bit more about the New York bill.
Yeah, definitely. And the LECLA bill, which first appeared in New York a couple of years ago now, and a version of it was signed into law in January by Governor Hochul in New York, has evolved a lot. And the different states where it's appeared, we call it jokingly LECLA Light, LECLA Classic, and Super LECLA. They all do different things. But the original LECLA kind of looked at buy clean and decided where can we use incentives as a way to drive innovation. And so the idea there originally was similar to actually what Adam was describing in the European context, because you see in places like Netherlands, where at the bidding stage, if a bidder is able to come in and demonstrate with EPDs that they have superior global warming potential numbers, those could get ranked, and then they could be given preferential treatment in a way looking sort of artificially less expensive than they actually are, and therefore become competitive. And so LECLA was originally that, and then a tax credit for concrete producers to get their EPD ability set up at plants. And then it was really voluntary initially. Where we are right now, actually, I just put it in the chat, is a successor to the LECLA bill, which we still call LECLA. You can call it Super LECLA, introduced in New York as the Climate Forward Concrete Leadership Act. And that actually takes buy clean and it introduces an incentive. So it creates, here's the floor, like buy clean, that everybody has to submit EPDs and you have to meet this. But if at the time of project, a concrete producer is able to, with an EPD, demonstrate that they fall below that threshold by a certain percent, then they're eligible actually for an actual financial bonus that they would get, similar to almost the way that you'd get for road smoothing or finishing a project on time. And so that's what that is. And then we also added a performance-based specification requirement, which is incredibly important for promoting innovation acceptance, as well as accelerated evaluation and testing for new low carbon materials by state agencies, just to make sure that any project can actually look at a range of different solutions and consider using them and understand how that might relate to their ability to get incentives. So it's kind of like a conglomeration of all the different best practices I think we see in different parts of the country right now.
Great. I want to remind folks in the audience that we are about to shift to Q&A. So please continue to put your questions in the Q&A button on your Zoom screen. And then the last question before we do so, I want to hear from each of you about how do we make it happen? How do we get this squarely in front of policymakers to educate and get folks aware of this opportunity to reduce greenhouse gas content in our built environment and sort of accelerate this transition. So Adam, I'm going to start with you and then go to Rebecca, then Eric, then Chris.
No particular comments on that one. I would just say that, in the past year, that's where it's been exciting to see that has fundamentally changed. So across the industry within the steel sector, which was certainly not the case years ago. So now there are, as you look globally, there are countries at different paces or different steps in the process. So there's certainly a lot of learning that can happen as you look internationally across how different markets are addressing different elements of that. But I think it's a lot of the industry groups like those on the call here today they're doing a lot of the heavy lifting to make sure people are educated on the work, and we're seeing the products of that work in the steel sector.
Yeah, I would agree. Like one thing that was helpful for passing the Colorado bill, although I wasn't really involved in that process before because I wasn't at RMI at the time, but there was a great participation from industry groups, especially Lafarge Holcim, which is a large concrete and cement company, and they were very vocally supportive of the bill. So I think that's been extremely helpful. And I think just in general, like we need more of an awareness campaign almost just to get more attention on this topic. I do think that it is a relatively easy, in quotes, again, lift. Like we have examples that exist already. We have Buy Clean California, Chris's work in New York. We have Colorado. So there's
and the federal government too, right?
And yeah, the General Services Administration of the federal government has a clean purchasing policy. The federal government introduced a Buy Clean policy. Lots of information in the Build Back Better bill. So there's definitely precedent now that will hopefully get the ball rolling. And I do think that like sort of an emphasis on co-benefits would be also really, really helpful here. So there's lots of co-benefits that come with this. This sort of includes, a health benefit of reducing hospital visits and health complications with, a reduction in air pollution from manufacturing plants. As we talked about earlier, this is like really supporting local manufacturing, labor jobs, and innovation locally here in the United States. And then using some of the, I think Eric called them the cement alternatives, or, the technical term is supplementary cementitious materials, which you use to replace cement. Like a lot of those things are industrial waste materials that would otherwise be dumped in a landfill and could contaminate groundwater. So this is an opportunity to use some of those waste materials and give them a new life. And I don't think that those sort of co-benefit points are talked about enough. So I think, yeah, general awareness campaign and talking about, you know, the precedents that exist and all of the benefits that are here for us to take advantage of.
I think two things that come to mind for me is the first is that legislators need to know that there is a constituency of interest for this, right? So if we're talking about the challenge of changing the status quo, do not assume that legislators are aware of this topic. Do not assume that they know who is supportive of this topic. So any communication that you have to say, hey, have you thought about this? You know, we have this climate reduction, emissions reduction plan. What are we doing on this topic? And I support the idea of this. That's really powerful. And as Chris pointed to, a lot of the success of these policies to date has really been driven by really passionate individuals who are not being paid to do this, who are not, you know, in behind any lobby group or anything. They are just one man, you know, womaning or manning the whole thing. And it's been really effective. So again, you do have that power, and legislators love to hear from their constituents. So that's one option. The other thing I would say is if you put yourself in the shoes of a manufacturer on the industrial side, if you are a practitioner, if you're an architect or an engineer, if you work for a local government, have you ever asked your concrete producer what options they can give you for lower carbon products? Have you ever considered that they might have options for you that you don't know about? Usually they are unfortunately in the situation where they just receive an order and are expected to fill it as written. That has not been proven to be very effective from a climate perspective. So Chris cited Portland. They did a study that suggested they could cut 30% of their carbon emissions from concrete procurement just by changing how they purchased the material itself. So this all sounds very complicated. It all sounds like there's a lot of moving pieces, but if you are a practitioner, the first thing you should be doing is just asking your suppliers, what can you do on a climate perspective, and making that part of your criteria if you can. Because if I'm a producer, I want to know that somebody wants to buy my product. And if nobody is asking me about climate, then there's very limited incentive for me to want to change.
Bringing the customers into the conversation.
Yeah, definitely. And also making sure, as I said before, bringing in the civil engineers very early on into the process. You know, I think that this time around, have had great partnership and engagement with the Office of General Services and different stakeholders within state government. They know what they're doing and they know what the limitations are. So you want to be having their input very, very early. And I think two other things, as I said before, focus on what's happening locally. And this is happening already, but let's connect all these different states and people that are thinking about it, legislators, their staff, so that people are really aware of best practices. NRDC in a couple of weeks, I was lucky enough to co-author with Caleb Woodall at Columbia, a guide to low carbon concrete procurement, which tries to sort of for that audience say, this is what's being done all over the place. And this is what you can sort of riff on locally. And then the last thing I'll say is we need to really segment cement decarbonization policy from concrete decarbonization policy. So one thing we realized is that when we introduced this concrete bill, which is a concrete procurement bill in New York, it attracted a lot of pushback from folks that in local communities that are concerned about air quality issues legitimately around cement. You don't want to, it's like the tail wagging the dog. You don't want to correct those issues or address them through a concrete procurement bill. So you really need a separate policy that's focused on the challenge of decarbonizing cement. And that really needs to be distinct from concrete. So that's just the last.
Which is a hard distinction to make for someone who's not in the business.
Yeah, hugely important. Everybody, even journalists, confuse those two terms. It's a joke within the trade, actually.
I'm sure they did. Yeah. So one thing we haven't talked about that came up in the chat is sort of the cost differential between, you know, low embodied carbon product and sort of the status quo. And Eric and Adam, I'd love for you to weigh in on that in the current state of technologies and where you see that sort of cost impact going over time.
Well, the kind of two elements to that. So on the capital cost thing, there's on the side of things, there's scale. So there's, as these new technologies get to the appropriate scale, there's also a timing element. You know, it's very different if you're talking about replacing a blast furnace at its end of life with a new green solution versus trying to incentivize taking a blast furnace offline a decade before it's at end of life. Those are two very different situations, but a lot of work being done to bring the technologies to scale so that if you are at a natural replacement point, these newer, greener solutions can be cost competitive. On the operating cost side, the other side of the overall cost picture, it comes down to the energy side of things. You're using the same feedstocks, iron ore, you're producing the same steels. you're making a very, very big change in the energy source, going from a coal-driven production to a electricity-driven process. And so that's really one of the key drivers, is where you can source very large amounts of renewables in a reliable and low-cost pricing. And that's really going to drive the where and when you need premiums of the sort.
So I'll give you the complex answer, which will be short, I promise, and then the easy answer, which will be longer. The complex answer is it depends, because
Like a
there's
good
lots
lawyer,
of different
right?
lots of different types of innovations out there. Not all of them are yet commercialized. We don't actually know yet what that will cost. But I think, as this innovation curve draws down with a lot of these investments, then we're going to see that become more competitive. One thing I would cite for CarbonCure is that our producer partners across the United States, they tend to sell product made with CO2 using our technology at anywhere from market rate or no change to a couple digit, single digit percentage point increases versus the raw material cost. That largely stems from their ability to obtain these efficiencies in their own production, which allows them to do that. But I would point out that we have many sidewalks and backyard pools in suburban Indiana where the owners of those products may not actually realize that that was made with CO2, because that was just provided to them at the same cost they've always seen the bid for. So that's good. But again, we need 100 more CarbonCures. And to do that, we're going to need to see the price continue to decrease for these innovations across the board.
Which I think also brings us to another question that came up in the chat, is sort of, are there still, from your perspective, serious technical challenges to get to that point, or is this more a sort of question of policy declaration, sort of awareness to really create that market share for low carbon products?
Well, I think, not to speak for Adam, but this is a whole new industry, right? Like, we're creating something that has no precedent. This does not exist yet. So yes, there are many difficulties ranging from the economic to the practical to the legislative to, all the above. So I think, that will be the great test over the next decade is how quickly can we conquer those challenges, and how many people can we bring with us to bring those solutions forward. Some of the things that we find as barriers you might find surprising. One of them is that buying carbon dioxide to use as an industrial product costs money. And it costs a lot of money. So this is one thing that is very perverse to me, is that here we are talking about the value of using CO2 and preventing it from going to the atmosphere. And to actually go out and buy that CO2 is incredibly expensive. And that's like a totally perverse thing. And if you read what the federal administration has announced, is that one of the major things they're looking at is, can they build these carbon capture hubs where they would be able to offer CO2 at a reliable, low rate. And I think that's actually going to be one of the key triggers in the concrete world anyway, permitting this to move forward, is if we can get access to reliable, low cost CO2.
That is counterintuitive for sure. Adam, you look like you're about to hop in.
Yeah, I'll just say in steel, one of the big things is that the blast furnace is an incredibly emitting process, but it's an incredible piece of engineering work where you've had centuries of innovation there, refining that process and all of the processes that go around that to get to an end grade of steel. So in some cases where you plug in a new technology solution, and it might not be all that big of a change to the overall flow sheet, but the person that optimized that one step of the process was an engineer 60 years ago, and it's been adopted. So you've got things where you've got to rethink. There are challenges that aren't, can be overcome, but you've got to find new people that can address them. We make a steel product. It's really a pure iron, molten iron. It doesn't have any carbon in it. So you have to, by definition, add a little bit of carbon to get to steel. Steel industry is very good at taking carbon out. It's a very manageable challenge to put it back in, a little bit of it, but they have to think about that now. How do I get carbon back into the iron to get to my steel grades, rather than how do I pull it all out? So just some of those types of challenges that have to be thought at the very detailed level.
And Chris, you look like you've come off mute.
Yeah, no, I think one really important, just in terms of the policy implications of what was just said, is that you want to construct policy. We have a long way to go, as Adam and Eric will be the first to admit. The solutions that are going to fully decarbonize these materials that are going to dominate, many of them are in the lab stage or sitting in a dissertation somewhere and are going to be the breakthrough technology. So when you construct policy, it can't be too prescriptive. You have to take advantage of what we know are best practices, but it should be open enough through performance-based specifications, accelerated evaluation, incentives, to let the market keep producing those and showing it to us so that we can then embrace a broader set of solutions rather than something that every 5 years gets looked at by staff, within state agencies. So that's it's got to be open, it's got to be innovation oriented, and it can't be too heavy handed in picking winners. And if it's going to do that, it better be able to take the hand off and identify new winners in time.
I think it's a really important point. You want to sort of focus on where you want to go, not the specific tools that are here today to get you there, but the sort of results you're looking at, and build your policies accordingly. I did want to note that the Reshma Singh put in the DOE's GREET model tool into the chat. So if folks are interested, take a look at that. I think the other question I had is that came up in the chat is, are there other building materials that we should be folding into this conversation? Insulation was mentioned. Other pieces that are out there that have an impact in the construction of transportation, buildings, other infrastructure.
I think it's important to, I don't know, when I think about all of the materials that go into making a building, it's so overwhelming, right? There's hundreds of materials that go into construction projects, but there are sort of these rules of thumb of where the embodied carbon hotspots are. So we know that a building or infrastructure's structural system, so that could be steel and concrete, wood, those, we know that system tends to be embodied carbon hotspot, using lots of materials that are high in embodied carbon. Another hotspot is sort of, at least within buildings, interior finishes actually do carry a lot of embodied carbon, as well as exterior cladding materials. So that could be glazing, windows, it could be exterior siding, and insulation would be included in that. So there's certainly ways to sort of narrow down what are the most important pieces of a building to look at in terms of materials and embodied carbon. A lot of some of the buy clean type policies that we're seeing try to address all of those or some of those. And insulation is a really interesting material because there are some insulation products that are carbon sequestering, right? So they're actually materials that are carbon sinks, and so is mass timber and other sort of bio-based products. And I as an architect get really excited about this idea that if you use more carbon sequestering materials than normal materials, your building is essentially a carbon sink. So you're no longer really a polluter or a problem, but you're a solution to the climate challenge that we have. So, and that's not that far-fetched. I don't think there's lots of materials out there that are carbon sequestering, Eric's product, and lots of different insulation and mass timber and all that stuff. So I like to sort of flip that on its head sometimes and think about, we're trying to look at sort of these hard to emit sectors, or hard to abate sectors, sorry. But then there's this other, flipping the coin, this other opportunity to turn buildings into these amazing carbon storing entities in our society.
And that should be our goal, I think. I mean, that really should be the aspiration that we're putting forward, is to go negative or go positive, and there's a great
however you want to look at that.
Yeah, exactly. That's Skidmore, Owings, and Merrill has a really interesting concept piece that they did called Urban Sequoia, which you can check out, which sort of embodies many of the things that Rebecca just said. But in terms of materials, I would definitely add asphalt in there, more on the transportation side. And what's interesting, the Netherlands, speaking to the program administrators for their CO2 performance ladder, which is one of those sort of bid discount programs, they, I think, have seen the greatest impact from that in asphalt. For whatever reason, creating that kind of incentive has actually led to the deepest drops in embodied carbon in asphalt. Not quite sure why that is, but that should certainly be under consideration.
I wonder, Chris, too, we don't know what we don't know, right? And when you think about, when you put investment or you put these requirements on industries that have never had to think about that before, sometimes we find out things that we never thought were possible. And I know, Adam, you were saying that the steel industry used the same approach for 60 years based off one man's invention. You know, when we all of a sudden start investing into this idea of, well, have you considered carbon? We don't actually know what's going to come out the other side. And so concrete is going through a bit of kind of a carbon renaissance right now, but all these other industries and materials, we should certainly be thinking about what opportunities lie there, which we might not even know about right now.
That is the history. And it's funny, you get called a techno utopian or optimist if you say that, but it's an empirical fact that we make enormous progress just by moving forward without assuming too much. And I think a lot of the pushback to your first question, Jeremy, is about who are the skeptics. It's a lot of people that are just looking backward at what's possible without acknowledging that, you know, just the number of things that change so rapidly because they're discovered as we move. That's what's going to happen. We're going to see more and more innovation, and we're not being utopians, I think, saying that. We're just pointing at what the history has been of innovation.
The actuality of today was the impossible of yesterday, right? I mean, I think that's a really good way to think about it. It's not it hasn't been static for 60 years. It's been a sort of a building of little and sometimes not so little innovations along the way. Adam, you look like you're going to hop in, and then I'm going to ask you guys the parting question.
Sure. So within the metals world, I certainly focused on steel, but there's innovation throughout. So what is one example? You know, the number 2 by volume metal is aluminum, about 70 million tons versus 2 billion tons for steel. So a different scale, but still, you know, in a lot of products, aluminum is the biggest emitting source. So there's a tremendous amount of work happening in the aluminum sector to do exactly kind of what Boston Metal is doing and be able to use electricity to deliver emissions-free steel. A different nature of challenge there for aluminum, but a lot of work happening there. And just like with steel, you're seeing the supply chain demanding and wanting to incorporate that emissions-free aluminum into their products, and that ripples down throughout all the other metals.
Well, great. I mean, this has been a great conversation. I think we could probably go on for another couple hours, but I do want to wrap things up. And before doing so, I want to give each of you the last word. And the prompt is, just having just talked about how we can't predict the future, I'm going to ask you to do so. So if we were to have this conversation in 12 months, what's the one most impactful thing that has changed in this space between now and March of 2023? And I'm going to go at random. And Rebecca, you're the unlucky one who has no time to think about it. Go.
Thanks, Jeremy. I would really love to see the Build Back Better bill passed in hopefully less than 12 months. I haven't checked in on it in a long time. I don't know where it stands, but there's one thing about that bill is that there's quite a lot of funding to go to manufacturers to create environmental product declarations, or these disclosure documents that are so critical, as we've already talked about. And I also know that there are a number of state level sort of buy clean type policies that have just been introduced to their respective, legislative sessions. And so it would be amazing to see more of those passed in the next 12 months.
Two things, a bonus. Adam.
Sure, I'll plug for Boston Metal here and say that we have our next scale up and system coming online in the next couple of months. So that pilot plant will be online, and we're also hiring at a tremendous rate. So if you're on the call or know others in the sector that want to come and be part of that next big leap in steel, please reach out.
So growth in the industry. Chris.
Yeah, my obsession, as Eric knows about, is I think within the next 12 months, we'll see the integration of direct air capture technology, which pulls carbon right out of the air, with technologies like CarbonCure, Carbon Belt, any of the carbon utilization companies. And I think that will be a massive breakthrough, both for low carbon concrete and for carbon removal. And I think that will happen this year.
And Eric.
I think, going back to the transparency theme, I think the activation of the federal government's buy-clean requirements for the GSA and Department of Defense are going to be the single largest flywheel effect on a lot of this work that's happening across the board. So to echo Rebecca on that, state procurement, the federal procurement is going to be a huge accelerator.
Excellent. Well, thank you guys very much for lending your time and expertise to us this morning. I want to give a virtual applause for all of you for making time for us. And now I want to turn it back to Joe to offer some closing remarks and talk about some upcoming events. Thank you so much.
Thanks, Jeremy. Folks, as Jeremy mentioned, please join me in thanking all our panelists and our moderator, Jeremy McDermott, for what was a fantastic and really informative conversation and discussion. I hope you found that to be. Great job. Great job. At this time, I'm going to make sure everyone's aware of some great events that are before us coming up. On April 14th, we'll be convening in Boston with our SPN, our Strategic Partner Network, for our grid modernization summit. All these things, obviously, we don't have to remind ourselves with the public. It's all interconnected, interlocked. Rhode Island Clean Energy Day will be April 27th, and Jeremy and his team are leading that. And the next Emerging Trend Series conversation, we'll really focus something near and dear to me, because there is a dearth and major gap in being set up to have impact is really deploying climate solutions at the local level and what that means. And we need more information coming on that in the very near future. I want to thank you all for joining us today. Jeremy, I guess I'll hand it back to you, talk here, but I hope you all can make those and other future events.
Great. Thanks, Joe. And thank you, everyone, for tuning in this afternoon or this morning. Look forward to the next Emerging Trends series in May. And we'll see you very soon. Signing off, and I really appreciate the time. Be well.
Thanks, Jeremy.